Let's go through Lico 3565 sequential grid path cover. So for this question, it give us an integer array grid and also integer k. So it's trying to see, let's find a path which can um, cover all of the grids. And also this path, and they need to this k, you say there is a number from 1 to k in these grids. And also k should be smaller or equal to the m multiplied by n, right? Otherwise, we don't have enough cells. So we need to find such a path. For each path, um, for the path, we should visit a cell, for example, from 1 to k in order. That means if we visit 2, right, we cannot visit 1 anymore. But since that is for 0, we can put that in any place. So for example, we can have 1, 0, 0, then 2, right? So it lets us to find such a path which can cover all of the grids, and return one path is good enough. So we'll see for this number, it is MN is 5 multiplied by 5, so it is kind of small one, right? So we can apparently do thinking about something to the DFS. This question is pretty much similar to the word search, the DFS part. But the things that here, the things that like a word is already, it's not necessary to be consecutive, right? But and also, the word is just 1, 2, 3, 4 to K, right? So, um, we just iterate the cells and the beginning starting point can be 0 or 1, right? So if it is the starting point is greater than 1, we should ignore. Then for each, if there if there is one path found, we just return. We don't need to find multiple one, right? And we DFS from the cells for every cell it goes to 4 directions, and we can actually use count. What we can put in the DFS is the count how many cells we visited. In the end, if we visited counts equals to n multiplied by n, then that means it's a valid path. And also there is a termination condition is that for this path, we can have a sin max variable, which means the maximal numbers from 1 to k we already put in the path, right? So that's if we already, for example, in this path, our maximum is 3, right? Then for next cell, we can only visit 0 or 4, right? We cannot visit 5 or any number smaller than 2, that is 3, right? That is a termination condition. So let's write code for this. Let's have it final static. Let's have a array define direction array, right? Was 1, 0, minus 1, 0, and also private final static int these. So what we need is let's have int m equals grid dot length and n equals grid 0 dot length, right? We need a result. And then we have for int I equals 0, I smaller than m, I plus plus, and also we need to have for int j equals 0, j smaller than n j plus plus, right? So we'll see only when the grid equals 0 or 1, which can put that as a starting point, right? So we'll say if grid I j, if this is greater than 1, we just continue, right? We cannot put this one as starting point. So also for DFS, we should have a weighted, right? So for every DFS, we're going to use a pass. Um, so let's have a pass list of integer. Um, list integer, because for the every element will be the coordinators equals new array list, and then we can have pass add list of I j, right? And we need to have a boolean boolean visited equals new boolean m n, right? So we can also set visited I j equals true, right? Then we are going to have DFS can have grid row column and grid ij. This is a maximal number in our path already, right? So it can be 0 or 1, right? And also we can have counts. The first one we have already have counts 1, right? Visited and pass and the result, right? So in the end, so here the thing is that if we already find a result, if for example pass is not result is not empty, then we just return result. In the end, just return result. Right. So let's have a DFS int grid and int row, int column, int the number max in our path, right? Int count how many cells visited, the boolean visited, and also list of list integer path, and also list integer result, right? So these were our DFS. So the things that let's have int m equals grid dot length and n equals grid 0 dot length, right? So let's say if this count equals m multiplied by n, that means this is a valid path, right? So result we should add all paths. Um, and we can add a return, right? So that the one not continue. So the thing is we need 4 directions for into here there is a key, right? So let's use L. Actually, this key is not used in our solutions, right? Because we just need to make sure uh, because the K, the one it is guaranteed that 1 to K is put on these cells, right? So we just need to make sure that we are going to increasingly have the Cmax in our path, right? So 0, L smaller than 4, L plus plus. So what we need is that we are going to have into new row equals row plus D row L, right? And into new column equals to column D column L, right? So it will say if new row is smaller than 0 or new row is greater equal to m, or new column is smaller than 0 or new column is greater equal to n, right? That is out of bound or weighted new row, new column, right? Any other thing? Also, we have another condition, right? Or this grid doesn't equal to grid new row, new column, unequal to 0, and it doesn't read new row, new column doesn't equal to C max plus 1, right? Then we need to continue. Then we are going to DFS to visit the add visit the new row, new column equals true, right? And visit the new row, new column equals false. Here we should have a DFS grid, new row, new column. C max. So this can be 0 or C max plus 1, right? So we can have max, C max, and grid new row, new column, right? And also this will be our count to the count plus 1, right? And verified and pass result. Here we should also, if we find one result, for example, if this result is not empty, right? We just return. We should return. We should not do DFS again, right? Otherwise, it will have some duplicates result in our path. So let's look. Um, so this will be false. Oh, we should add it to the path, right? So path add list of new row, new column, and also with this with the backtrack, the path remove path dot size minus 1, right? Okay. Um, the time complexity will be for every cell it have four directions, right? So let's say so it will be 4 power m multiplied by n, right? Yeah. And also um also so um, this will be the order like this. And um and also we should read each cells, right? So it will be m multiplied by n, 4 power m multiplied by n. And space will be O m multiplied by n, right? We can also write the Python code for this. So we're going to have, for example, m n d row d column equals length of grid and length of grid 0, and this one will be 1 0 minus 0, and this one will be 0 1 0 minus 1, right? And we can also have a result here because empty list. So for I in range M and for J in range N, right? So let's say if we grid I J is greater than 1, we should continue. Um, then we're going to for every DFS we create our own weighted equals false multiplied by n for this one in range M, right? And weighted I j equals true. And then pass equals, let's have pass right? Then we're going to have self.dfs grid ij. Um, this will be the maximum number in our path already, right? So our count is one awaited path result. We can have a D row, D column here, right? So that otherwise we can put this one as use a self in the stack outside, right? So if result is not empty, we just return result. Then it just return result, right? And we should also have the DFS self grid row column Cmax count rated as result the row the column. Okay, so the things that n equals length of grid and the length of grid 0. Then we're going to, if count equals n multiply n, right? Then we just result extend and has add all of that, right? Then we should return. And we'll say for L in range 4, right? So we'll say new row, new column, new row equals row plus D row L. And new column is column plus D column L, right? So what we need is that if new row smaller than 0, or new row is greater equal to M, or new column smaller than 0, or new column is greater equal to N, right? Or weighted new row, uh, new column. Here we'll have all, right? Or we have another condition is that grid new row, new column done equal to 0 and grid new row, new column done equal to C max plus 1, right? In this kind of condition, just continue. So otherwise, we do backtrack, right? Related the new row, new column equals true, and pass dot append, new row in the new column, right? So also we need a pass pop, and also weighted new row, new column equals false, right? So here we DFS. So we'll say self.dfs. So we'll have a grid, new row, new column, max, say max, and grid, new row, new column, right? And count plus 1, and weighted has result D row, D column. So here we'll say if result, you should return, right? So this will be